Hello children, welcome back to my channel. Now I am dealing with 8th class maths factorization, a new topic. What is meant by factorization? Factorization means finding factors of a number. Suppose as an example, we are taking number 42. What are the factors of 42? 42 can be written as 1 into 42 and 2 into 2 twos are 2 ones are 3 into 3 ones are 3 fours are 4. With 4 you cannot do it. 5 no. 6. 6 7 are 42. 7 of course. 8 9 10 you don't get anything. These are the factors. Therefore factors of 42 we can write it as 1 2 3 6 7 14 21 42 in an order. So this is a normal factorization. You can find out factors starting with the table 1, 1, 2, as a 3, whichever table the given number goes, that table we need to think about and we have to find out. So in this way, you can find out the factors of the given number. Now, we need to find out what do you mean by prime factors. What are prime factors? If you want to know about the prime factors, let us have a small discussion about prime numbers. What are prime numbers? Already you have been discussed, or you might have done a lot of problems about prime numbers. Just as a recollection, because we need to talk about prime factorization a lot. So let us find out let us have a recollection about what are prime numbers. What is a prime number? A number which has factors has 1 and itself. So it is having factors as 1 and itself. See, suppose you have taken 42. 42 when you are doing 1 and itself means 42. You have many more numbers here where you can find out the factors for the given number. So you cannot consider it as a prime number. So what is this number called if it is not a prime number? Other numbers are called. They have a specific name, children, composite numbers. So, this is only a recollection, children. Recollection for you. What are prime numbers? What are composite numbers? You know already, just a brushing out of your knowledge. So, we are going to talk about prime factors. So, suppose you have got a number in your textbook itself. You have got a number 70. So, prime factors of 70. Number 70. So, how will you find out? Take 70 children and go for only prime numbers. Don't talk about the composite numbers. And we know that a specific representation of number 2. 2 is the only even prime number. Remaining all prime numbers are odd, but only 2 is an even prime number. Specification about the 2. So here I am starting with 2 because it can be cancelled by 2. Units plus 0, divisibility property. So it can be divisible by 2. So I should start with that number. So 2 3s are 6, 2 5s are 10. So units plus 5 means with 5, 5 is also a prime number. 5 7s are 35. That's all. 7 is also a prime number. Therefore, prime factors of 70 are what? 2, 5, 7. This is the answer, children. Prime factors means you don't get 1 because 1 is neither prime nor composite. So we don't consider 1. Right from 2 we are going to talk about, and you should write only prime numbers here to solve the problem. I hope I am clear, children. Please note it down, then we will go to do these sums. Now let us go for do these sums. What are these do these sums? Express the given numbers as in the form of prime products. In the form of product of prime. Product of prime. That means you need to find out prime factors. First one, 48. So when you take 48, it can be cancelled by 2. 2 2s are, 2 4s are, again 2 1s are, 2 2s are, 2 6s are, 2 3s are. Therefore, prime factors of 48 are, what are the 2, 2, 2, 2, 3, or you can even write it as 2 to the power of 4 into 3. Even this way you can write as prime factors, children. These are all factors separately if you write, or you write it as 2 to the power of 4 into 3. This is your answer for this bit, children. Next. Of course, he has given that express the given numbers in the form of product of primes, means when you have talked about this, we can even write it as 2 into 2 into 2 into 2 into 3. These are all products. That is nothing but 2 to the power of 4 into 3. Now we have got another number 72. 72. So when I take 72, 2 threes are, 2 six are, 2 ones are, 2 eights are, 2 nines are, 3 threes are. 3 threes are 9. So prime factors. What are prime factors? 2, 2, 2, 3, 3. Therefore, products, how will you write prime products? Products as 2 into 2 into 2 into 3 into 3. That means 2 to the power of 1, 2, 3 into 3 to the power of 2. This is the answer for second bit, children. Now let us go to the third bit. Third bit, 96. So take 96 again with 2. 2 fours are, 2 eights are, 2 twos are, 2 fours are, 2 ones are, 2 twos are, 2 six are, 2 threes are. So prime factors are 2, 2, 2, 2, 2, 3. So what are the products? If you write it in the form of products, 2 how many times? 1, 2, 3, 4, 5 times. 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5 times 2 I have written into 1 time 3. That is nothing but 2 to the power of 5 into 3. This is the answer, children. So these are all the answers for this problem, so children. So I hope I am clear here. You have to find out what are the prime factors. So when you are doing prime factors, here what are the numbers you are taking? These all should be prime numbers only. And the smallest prime number is 2. So we start with 2. In case if the given number is divisible by 2, if it is not divisible by 2, next prime number, that is 3. You can go with that. So gradually you need to select only prime numbers here. You cannot go for the other number. I cannot write it as 3 into 1 because 1 is neither prime nor composite. So I should end it here itself. I am not supposed to continue it. I hope I am clear, children. Please note it down. Now let us talk about factors of algebraic expressions. So just like how we have done factors of the numbers, we are going to talk about factors of algebraic expressions. So let us talk about 7xyz. What are its factors? The factors are 7 into x into y into z. Separately we need to write. Now another one, we have got 7y into z plus 3. So when we have got any number in the bracket, it should be taken as a single number only. Don't consider this as two numbers. So here, what are the factors for it? You will write factors are 7 into y into z plus 3. You have separated the factors. Next, you have got 5x 5x into y plus z. These factors, how will you write? Factors are 5 into x into y plus z. We cannot differentiate y plus z, children. So in this way, you are going to separate the factors. Now you have do these sums in this. Let us see the do these sums. The first one, this is find the factors of the following. The first problem here is find the factors of the following. So let us see the first bit. 8x square yz. So here, see children, here we have got 7 means it has got 7 itself, its factors. So here 8 means what you can say? 8 can be written as 2 into 2 into 2 into x square, 2 times x into x into y into z. These are the factors. What are they? 2 into 2 into 2, that is 2 to the 4, 4 to the 8. And x square, x 2 times multiplied, y once, z once. Second bit. 2 xy into x plus y. So these factors are nothing but 2 into x into y into x plus y. This is separately we have to write, children. It will not come under this. Now, third one, we cannot write x into x. Okay, next 3x plus y cube z. Now in this 3x into y cube plus z, this can be written as 3 into x plus y into y into y into z. But see, there is a plus here. That means you cannot make any factor. There is no common element here so that we can take it out. So we will say that there are no factors for 3x plus y cube z. These are all the answers, children. In case, if you want to find out, these are all actually prime factors I have taken. This problem, if you want to write as normal factors, what are the factors of 8? 8 means 1 into 8, 2 into 4. That's all. 4 twos are or 2 fours are. That's all. So you can even write its factors as 1 into 2 into 4 into 8 into x into y into z. So this is the answer when you are going for prime factorization. This is for prime factorization when I am talking about prime factors, and this is for only factors. So in case if this problem is asked to find out the prime factors, write it like this. Just the factors means you write it like this in both the ways I said. And this is, there is no difference, same, because the 2 itself is a prime number and here there are no factors. Please note it down, children. Now let us see about need of factorization. Need of factorization. Why do we need this? So factorization is used in algebraic expressions to simplify the given algebraic expression. This is the main reason, children. Why are we using this factorization in algebraic expressions? We can simplify it. For example, see, you have got a number given 23a plus 23b plus 23c. So in all these cases, 23 is common. So you can take 23 out and see here 23 is out, so we have a plus 23 is outside, so we have b, plus this 23 is outside, you have c. So see, you can simplify this in this way. That is the reason why we need algebraic expressions. Next we can take another example. Another example is given as, see, two bits are given. First one, x square y plus y square x plus xy. See, this is an algebraic expression in which you can see x and y are there in all the three. So you can take x and y as common. So here when you take x and y, one x and y is out, you have got one more x because this is x square. So only x you will be getting, plus. Here also x is out, one y is out, only one y will be there. Plus both xy's are out, so we need to write 1. Don't forget, children. If you don't write this one, what will happen? This xy will be missed when you open the bracket. This is the first bit. And you have another bit also here. The second bit given here is 4x square minus 1 divided by 2x minus 1. So this division can be very easily done when you go for prime factor, the factorization. This is because 4x square minus 1 is nothing but 2x whole square minus 1 whole square. So this is in the form of a square minus b square, which is nothing but a plus b into a minus b. So 4x square minus 1 by 2x minus 1, division means by 2x minus 1, can be written as 2x plus 1 into 2x minus 1 divided by 2x minus 1. So what is happening? This 2x minus 1 and 2x minus 1 you can cancel. 2x plus 1 is the answer. See, it is so easy for you to find out a solution for it when you go for factorization. Please note it down. Children, let us see the next part. Method of common factors. For this, an example that is given to you is 3x plus 12. So if you have like this, for each term, let us factorize. 3x can be written as 3 into x. Let us keep it in bracket. Plus 12. Let us find prime factors of 12. 2 6 are, 2 3s are. So 2 into 2 into 3. So in this, what are common factors in these? Let us underline. 3 is common, nothing else. So let us take this common factor out into. So in this is taken out. So what is left behind? Common factor is only 3 children. 3 we have taken as common factor, no need to write into, just you put bracket. That itself is the meaning of into. What is left behind here? X plus. This already we have taken, 2 2s are 4. Therefore, 3x plus 12 can be written as 3 into x plus 4. So, common factor, method of common factor means we are taking out common value and simplifying the given algebraic expression. Now, one more value that they have given is 6ab plus 12b. So 6AB, 6 means 2 into 3 into A into B is 6AB expansion plus 12. 12 already we have written here, 2 into 3 into B. Now in this what are common? 2 is common, 3 is common, B is common. So what you will write? 2 into 3 into B into these 3 common have come out. So what is left behind? A plus 2 has gone out, 3 has gone out, B has gone out. You have only 2. So here 2 3s are 6B into A plus 2. Therefore, 6AB plus 12B is equal to 6B into A plus 2. This is the simplified answer for this problem, children. So, even if you can check whether you are right or wrong, just by multiplying 6 into A into B, 6AB, yes. 6 2s are 12 into B, 12B. I have got it as it is. So, please note it down. These are some of the topics given to you in your textbook for an explanation of common factors. Example 1, factorize 6xy plus 9y square, first bit. Second bit, 25a square b plus 35ab square. So let us take the first one. 6xy plus 9y square. So when you find factorization, 6 can be written as 2 into 3 into x into y. Okay, plus 9 means 3 into 3 into y into y. So out of these two, what is common? 3 is common, 1 y is common. So when we take 3y out, here left behind is 2 and x, plus here left behind is 3 and y. Therefore, 6xy plus 9y square is equal to 3y into 2x plus 3y. This is the answer for this problem, children. We can even check 3 2s are 6, x into y, xy, plus 3 3s are 9, y into y, y square. So our answer is correct. Next, let us see 25a square b plus 35ab square. So 25 means 5 into 5 into a square, a into b, plus this is 5 7 5 into 7 into a into b into b. This is the expansion. So common 5 is there and a is there, b is there. So what we are getting? 5ab is common into, so this is taken out, this 5 is left behind into this a is left behind, plus here 5 is taken out, so 7 into a and b have gone out into b. That means 5ab into 5a plus 7b. Therefore, 25a square b plus 35ab square is equal to 5ab into 5a plus 7b. So 5 5s are 25, a into a square b plus 5 7s are 35 a into a, there is no a, so I wrote a here, b into b square. So our answer is right. Please note it down, children. These are the factorizations. Very important, children. Don't forget it. The problem, children. The problem is 3x square plus 6x square y plus 9xy square. We need to factorize it. So as we have done in the same way, here 3x square, 3 into x plus 6 means 3 into 2 into x square, x into y plus 9x y square. 9 means 3 into 3 into x into y. So this is one, this is second one, this is third term. So in all these 3 is common. In all these x is common. That's all. Y is there in both of this, but there is no y here. So common is 3x. So 3x into here left behind is x plus this has gone, 2xy. 2xy plus 3x has gone, 3y square. So 3x into x, 3x square plus 3 2s are 6, x into x, x square y, 3 3s are 9, x y square. So our answer is right. Therefore, 3x square plus 6x square y plus 9xy square is equal to 3x into x plus 2xy plus 3y square. This is the answer for this problem, children. Please note it down. Now do this sums, children. Factorize. First one, 9a square minus 6a. Earlier we have plus, now minus. 9a square can be written as 3 into 3 into a into a. This is the expansion. Minus 6 means 3 into 2 into a. So this is equal to 3 is common, a is common. So 3a when I take it out, I am having 3a here minus 2. Therefore, 9a square minus 6a is equal to 3a into 3a minus 2. See, 3 3s are 9, a into a square minus 3 2s are 6, a. This is the correct answer. This is first bit, children. Second bit, 15 a cube b minus 35 ab cube. 15 means 3 5s are into a cube, a into a into b. This is one group minus 35, 5 7s are into a into b cube, b into b, 3 times b. So in these two common is 5 and a and also b. So this is equal to 5ab. If you take 5ab as common, 3 into a I am getting 3 into a minus 7 into b. That is 5ab into 3a square minus 7b square. Therefore, 15 a cube b minus 35 ab cube is equal to 5ab into 3a square minus 7b square. See, 5 3s are 15, a into a square a cube b minus 5 into 7 35, a into b square b cube. So we have got the same thing. This is the answer for the second bit, children. Now I will do third bit here. What is the third bit? 7lm minus 21lmn. So 7lm can be written as 7 into l into m minus 21 means 7 into 3 into L into M into N. So in these two, common 7 is common. This is one and this is one group. 7 is common, L is common, M is common. So I'll take 7LM here. So when I take 7LM here, there is nothing left here. But we cannot just omit it and write only this. In this place, we have to put 1. Why should we keep 1? Because when you are opening the bracket, this into 1 becomes 7LM. If you don't place 1, you directly write this, then this part will be missing. So always be careful. If you are taking all these values out, you are supposed to keep 1. Minus 7 has taken out 3 into what is there? N. So what am I getting? 7LM into 1 minus 3N. That means 7 LM minus 21 LMN is equal to 7LM into 1 minus 3N. Is it right or wrong? We see 7 ones are 7, L into M, LM minus 7 threes are 21, LMN. So our answer is right. So this kind of checking should be done, children, and at the same time, don't forget to keep 1 here. That is very important. If you don't keep this one, your answer will go wrong. So for the sake of convenience, I will just draw the lines, children, so that you won't get confused with the answers. So I hope I am clear, children. Please note it down. Now the next part is factorization by grouping the terms. So here you have ax plus bx plus ay plus by. So we need to group them. Let me make these first two as group, these two as one group. In these two, x is common. So I'll write it as x into a plus b plus, in these two, y is common, y into a plus b. So what is the factorization here? A plus b into x plus y. So by grouping them, you are able to do them. Find the factors. You can even do it in this way, or let me take a values together plus b together. This is one group, this is one group. In these two, a is common, a into x plus y plus b into x plus y. So this is nothing but a plus b into x plus y. So see, children, in any way you are getting the same answer. So this kind of grouping is called factorization by grouping the terms. Now you have got one, do this sum, children. Two sums are there, do this. Factorize. First bit 5xy plus 5x plus 4y plus 4. So let me take this two as group, this two as one group. In these two, common 5 into x. So what is left behind? Y plus, see, total 5x is here, so 1. Already I told you about this, plus. In these two, common is 4. 4 into y plus 4 is out, plus 1. So what are you getting? 5x plus 4 into y plus 1. These are the factorizations for this problem, children. Now second one, 3ab plus 3a plus 2b plus 2. So let me take this as one group, this as one group. In this common factors are 3a. So b plus 1 plus 2 into b plus 1, 2 is common. So 3a plus 2 into b plus 1. These are the answers for this problem, children. So this kind of grouping here I have explained in both the ways. It is not necessary every time to do both the ways. You can do it in only one way. Any one of these ways is enough of easy for you, children. I prefer to take the first two, second two like that. That is direct problem. So you'll be getting answer easily. Please note it down. Now, example 3. What is it? Factorize 6ab minus b square uh, minus 2bc plus 12ac. So the problem is 6ab minus b square minus 2bc plus 12ac. So these two as one group, these two as one group I'll take. In this, what is common? B is common. So when you take B as common, what are you getting here, children? 6a minus b minus, in these two, common is 2. 2 and c. If I take 2c as common, I am getting b. See, this is plus means there is minus, so I should write minus. Minus into minus becomes plus. 6a. So here 6a has got a plus sign and b has got minus sign. But here b is having plus sign and 6a is having minus sign. So you can even write this as b into 6a minus b plus 2c into 6a minus b. So when I take it like this, 6 2s are 12 AC with plus sign I got. Plus into minus, minus 2b into c is 2b's, minus 2b's. So in any way you are getting it as the same answer. So what did I do, children? In this, b is common. B into 6a minus b I wrote, and I took minus here, so I took minus here. In these two, 2c is common, I have taken. So here 2c I have taken, so b is left behind. And though there is a plus sign here, I should take minus here, because when I open the bracket, minus into minus becomes plus. So minus I have taken 2, 6 are 12, C is already there, E. But you see, children, see, always this bracket value should be same. But what is happening here? B is having plus sign, B is having minus sign. 6a is having minus sign, 6a is having plus sign. So signs are different. So to make these two signs are as equal, I should change the sign here. So I made minus as plus. So that 2c into 6a minus 6a becomes plus 6a plus b becomes minus b. So whether I am correct or not, I have checked. How did I check? B into 6a, 6ab. Plus into minus, minus b into b, b square. This part is right. Now plus into plus, plus 2 6 are 12 AC, plus 12 AC I got. Plus into minus, minus 2 BC I got it. So my splitting is correct. So this is equal to 6a minus b into b plus 2c. This is the answer for this problem, children. Please note it down. With this, I'm going to conclude my part today. In the next class, I'll be doing the exercise sums.